we can think of our testing as an instrument, just like any other measurement instrument. So just like a ruler to measure how long something is, or what have you, the same thing is with our testing. Just as with all these other measuring devices, the testing procedure has a detection limit. So for example, if you buy a cheap ruler, your detection limit might be to the closest inch or centimeter, or how cheap your ruler is. Whereas if you had an electron microscope to measure the distance, the length of something, you'd have a much tinier detection limit. So what is the detection limit of our testing device? Well, let's look at the formula for measuring prevalence, and we see that it's the ratio of two quantities, and we've got the denominator and we've got the numerator. What do we know about prevalence? Well, prevalence has to be non-negative. It cannot be a negative number. So let's work with that. That means that either the numerator and denominator are both negative, or they're both positive. I'm going to work out the case when they're both positive, and I'll leave it to you to figure out the case when they're both negative. So in order for them to be both positive, let's look at the numerator. This means that we want the proportion positive minus this is greater than or equal to 0. That means that the proportion positive has to be greater than or equal to 1 minus the specificity. So if the proportion positive gets below that, then we're in trouble, because then this quantity would be negative. How about the denominator? Well, now we want that the sensitivity minus the specificity, minus 1 minus specificity, is greater than or equal to 0, or sensitivity plus specificity is greater than or equal to 1. Now, if we just flip a coin to make our decisions, we'd have a sensitivity of 1/2 and a specificity of 1/2. And so that's asking, so this equation here is asking that our measuring instrument be better than flipping a coin. So let's assume that that's always the case. In this one we just looked at, we had a sensitivity of 0.733 and we had a specificity of 0.97, so that's well within this. So here it is. There's the constraint. We cannot go and expect to measure prevalence that yields a proportion positive, a very, very tiny proportion positive. What do I mean by very, very tiny? I mean that it has to be greater than or equal to 1 minus the specificity. So that's the lower bound to the detection limits in our measuring instrument. So let's look at an example of this. Here's the result of HIV newborn screening in New York State in the period November 87 through March 90. Now, this is old data because they used to test all babies at birth. They would prick their heels and take a look at the blood spots from the heels, but then some politicians got involved, and as a result we don't do this anymore. This is not done anymore. But let's look at what happened when we do have the data. And they broke this up into two regions. The top one is New York State, not New York City, and there were 601 babies tested positive of the 346,522 births. So the percent positive, so the proportion testing positive is 0.17%. In New York City itself, these are the 5 boroughs of New York City. In New York City itself, there were 3,650 babies testing positive of the 294,062 births. So there the rate was 1.24%. All right? So let's take a look at some of these numbers here, the very, very low rates, and let's ask how possible is it that these are truly positive? Well, we said that we want the proportion positive to be bigger than or equal to 1 minus the specificity. In our upstate urban New York, there were 119 who tested positive out of the 98,088. So that gave us a 0.14% proportion positive. So if we plug this in here, what does that tell us about the specificity? If we plug that in there, we get that the specificity has to be greater than or equal to 99.86%. It's a tall order. So we don't expect that indeed these 119 were truly positive. In order to detect that, we would need a very, very precise measuring instrument, better than 99.86% specificity.